Welcome to New Focus Approach Mathematics Basic 9. This is the revised edition, and in this video, we want to revise our knowledge on constructions. In this book, we put constructions into two, that is the construction of triangles, that is part 1, and construction of quadrilaterals, that is part 2. And this lesson can be found in page 150. We did in year 2, that is book 8, how to construct triangles given various conditions. We've learned that already. Now we want to just add more value by solving more questions so that we can master the construction of triangles. And so we have one question here we want to do or want to solve. Now the question says, using a pair of compasses only, construct triangle PQR where the line PQ has been given, line PR given as 7 and QR given as 8. Now locate the point A in the center, which is equidistant from each side. Let's remind ourselves that when we say equidistant from each side, that means we are looking at the locus of a point which is equidistant from 3 fixed lines. Okay, so now let's start our construction using the dimension given. So we want to do PQ. So we have our point PQ constructed with the dimension of 10 centimeters, which you can do that. You put a compass pin on your ruler and measure 10 centimeters, and then you put it at point P, and then you strike to get that of the Q. Now, because we want to construct a triangle and they give us PR, let's put a compass pin at Q. Okay, now we have QR as well, so let's put a compass pin at Q and measure 8 centimeters using your ruler, okay, which I know you can do that. Now you draw an arc, just an arc with your 8 centimeter. Now remove the compass pin and put it and measure another one, that is the 7 centimeters, that's PR, and then put the compass pin at P and draw another arc to intersect the first one. Remember that since 7 centimeters is less than 8, you get your diagram looking like this. So when you position your R, which is the point of intersection of the two arcs, you use your ruler to join the line from P to R, then R to Q, and that gives you your triangle. Okay, remember this is not drawn to scale, but if you draw yours to scale, you might not get a shape exactly like this, but it will just give you an accurate answer. Now we are done with the triangle. We want to locate a point, okay, which is equidistant from 3 fixed lines. And so what we do is that we put a compass pin, or we are going to bisect any of the two of the three angles that we have. We're going to bisect any two of the three angles. So let's put a compass pin at point P and draw any convenient arc. Okay. Now where the arc intersect the two lines PR and PQ, put a compass pin at one point and then open it to any radius and draw another arc. Now with the same radius you use here, put a compass pin at where the spot red is, okay, and then draw another arc to intersect the first one. Again, we are going to join the point P through the two intersectional lines, which becomes an angle bisector. Okay, so we are done. We are going to do the same thing at Q. Put a compass pin at Q, draw an arc. Now you can change the radius and put a compass pin at the point of intersection of the line and then the arc, and then open to any convenient radius and draw another arc. Now with this radius, don't change it. Put a compass pin at the opposite side of it and then draw another one to intersect the first one. Again, join the intersection to the point Q, and that will give you another bisector of angle PQR. Now we have the meeting point of the two bisectors, so that is going to be a point, and that is going to be the point A that the question asks us. But we are not done. We need to know the radius of the circle we are going to use to draw this very inscribed circle. Remember, this aspect is talking about more of inscribed circle and circumscribed circle. So we put our compass pin at the point A here and open to any convenient radius to draw an arc to intersect the line PQ. The same radius, draw another one. Okay, now with these two arcs that you have, put a compass pin at one point and open more than half of this and that and construct an arc. Put it to this place and then construct another arc to intersect the first one. Now join the intersection to the line A or the point A, and that become a bisector, right? But it become perpendicular line to the line PQ, and that is what we want to do. So we can use the point A and then the point here as our radius, and then draw the inscribed circle, and that will answer the question, right? I'm sure that is clear. Beautiful. Let's take another example and see how we can solve other questions. Three towns are linked by three straight roads. Will be 4.5 kilometers from Eyikuma and 7.5 kilometers from Dodowa, whilst Dodowa is 6 kilometers from Eyikuma. We want to construct a representation road linking the three towns. Then locate a gas assembly point which must be positioned such that it is of equal distance to each road. What is the distance of this gas assembly point from each road? Okay, so that is the question. So first of all, we just want to have a straight line, and they want to position Oyibi and then Eyikuma, and according to the question, the distance between them is 4.5. So we just draw 4.5 kilometer, and this is kilometer, and we are dealing with a small sheet of paper, and we can't have kilometers, so we convert it to, or we scale it down by using maybe 1 kilometer to be equal to 1 centimeter, and so our 4.5 kilometer become 4.5 centimeters. Okay, good. Now the question says from Eyikuma to Dodowa is 7.5. So we measure 7.5 centimeter on our ruler with our compass, and then put a compass pin at A and draw an arc. Okay, now then remove your compass. Now take the measurement of Oyibi to Dodowa to Eyikuma is 6 kilometers, so that's what we've done, 6 kilometers. Then from Oyibi to from Eyikuma to Dodowa, so we measure 7.5 kilometer. That is the measure from Oyibi to Dodowa, and then we draw an arc that is 7.5. Now when we join these three towns, we'll get a triangle like this. And once again, since we want to locate a filling station or gas station at the point of intersection where we can have a distance from that center to all the three roads. These are the roads. The roads are the lines that we have here. So once again, we bisect two of the angles as usual, and then we bisect this one too as well, and we create two bisectors. When they meet at the point, that point becomes where we can locate our filling station, and so, or the gas station. So let me call that place J, the gas station point. Then we use that point to construct a perpendicular line to the line OA. So we put a compass P at J, open and draw an arc, the same radius, another arc. We are going to bisect these two arcs. Put a compass pin here, draw an arc, the same radius, put it over here too, and draw another arc. Is that okay? Now join this line to J, and that becomes our radius. And so when the question asks you what is the distance from the gas filling point from each of the road, then it means that when you measure the radius of this, that becomes the distance from each of the road. Then you can now use it to draw your circle, right? So that is how we can answer questions using or we can solve questions involving inscribed angle. And if it is circumscribed, you bisect the two lines. Okay, you bisect the two lines, and then another two lines, and that one you draw the intersection and draw your circle as well. I'm sure this has been of great help to you. Thanks so much for watching.